Hi everyone, welcome to our 6.3 lesson. This is part 1 and we're looking at domain and range. This lesson is going to be broken into 3 parts. So the first part we're going to talk about what is domain and range and how to write the domain and range of a graph in words as a number line or as a list. And parts 2 and part 3 will deal with some other ways of writing domain and range. So let's go ahead and get started. First of all, when you're looking at a graph, we can look at the graph in 2 ways. We can look at the x values on a graph, so sort of the range of x values, and also sort of the range of the y values. And we use these 2 different terms, domain and range, to talk about what are all the values of x and what are all the values of y. So the domain is all the set of x values, or whatever your independent variable is. Okay, so it's all the possible x values that are represented by the graph. So it's the set of numbers that define the independent variable. So sorry, I could have wrote that right there. So the set of numbers, so all the possible values for whatever the independent variable is. Usually it is x. And what that really means is that the domain is the limits of x values. So we'll state the upper limit and the lower limit, and that's called the domain. It's x goes from here to here. The range is the set of all the y values that are represented by a graph, the same graph. So it shows the vertical up and down range. Okay, and it's the set of all the numbers that define your y variable, or what is called the dependent variable. So sometimes you're not graphing x and y, and so the range would be whatever the y, what would be on our y-axis, so the dependent variable. Okay, and again, so it's just the limits of y, okay, values. So it tells us what's the lowest value it can have for y and what's the highest value, and then we assume it's everything in between those as well. Okay. So let's go ahead and have a look at this. There is a really easy way to remember that domain talks about x values and range is referring to y values. So this is sort of a memory trick that's really helpful. Okay, so here we have a little memory trick. I like to remember that when you're looking at a point on a graph, x always comes before y. That's always true. X comes before y. And in the alphabet, domain starts with D, and D comes before R in the alphabet. So D comes before R in the alphabet, and that helps me remember that domain is referring to X, and range is referring to Y. So that might be helpful for a little bit of a memory trick. So D comes before R in the alphabet, and X comes before Y when you look at a point on a graph. So D goes with X, and R goes with Y. As you get used to them, you'll probably just start to associate domain with X and range with Y, but this is a helpful trick. Let's go ahead and do some real examples here. So we're going to just first look at what is the upper and lower limit. So on a graph, if I see a table of values in ordered pairs, and then we're going to learn how to write properly domain and range. So if you're looking on a graph, your domain is your lower limit of X to your upper limit of X. So if I look at this graph, I see that, the first point of my graph looks like it's right here at 0, 0. I could mark that on my graph, 0, 0. And I see that my graph is a straight line, it's a linear graph, and it ends up here at this point. And that is the point, if I look at my graph, if I come down to my X, that's the point 4 for X. And if I come over to my Y, looks like it's at 4 as well for my Y. Okay. If I count up 4 boxes. So I can see that the domain, okay, or the horizontal change in my x values goes all the way from 0 to 4. So this is my domain. So my domain is all my possible x values, and they are x, okay, is the values of x I should say XR, from 0 to 4. Okay, that's the domain. The range is the vertical range here, and I can see that y, the lowest value of y is 0. So here's my range. The range is 0, again, all the way up to 4. So the greatest value of y is 4, right here, and that's my range. So from 0 to 4 on my graph. So your range is always your vertical range, and your domain is all the possible values along the horizontal here for x. If I'm looking at ordered pairs, okay, again, I can simply look at the pairs and say, well, what is the lowest value that I have for x? What's the highest value that I have for x? And that's my domain. So my domain refers to the x values. Remember, those are your x values. And if I look at these points, remember that a point when it's written as an ordered pair, it's written as a point. Okay, a point is always x and then y in terms of the order of the numbers that you see. The x coordinate is first and then the y. So that tells me that when I'm looking at my domain, I should look at the first number here. And I see that the smallest number of all of these pairs is 1. Okay, I have 1, 2, 3, 4, and 5. So my domain here is going to be from 1 up to the highest value, which is 5. There's my domain. So it goes from 1 to 5. My range will be all the possible values that I have for y. And again, if I look at a given point, y comes second. So I have the lowest value is 1. And it goes all the way up to 5. And so again, it just so happens that I have the same range here from 1 to 5. Okay. On a table of values, it's the same thing. When you're looking at your x values, that's your domain. So here's your domain. These are all the possible values of x. If we looked at the smallest value, I see it's -2. And it looks like the biggest value here is 5. So there's my lowest value, and there's my highest value. So that's my domain. It's from -2 to 5. Okay, my range will be all the possible values for y. And again, here, if I look at the values that I have, I see that I go from -3 is my lowest value, all the way up to +5. And so I would say -3 to 5. Those are my limits. The lower limit is -3, the upper limit is 5. And there are some values in between. Okay, now let's talk about how to properly write the domain and range, because we don't write it like this, 1 to 5, -3 to 5. That's not how we write it properly. We have to give a little bit more information than that. So there are several ways to show the domain and range, and we're going to look right now at how to describe it in words, how to use number lines, and how to use a list. A list is only when you have discrete data. Okay, so we're going to do this in part 1. And later we're going to look at interval notation and set notation in parts 2 and 3. So let's go ahead and get started. We've got a couple of graphs here. We're going to use some words to describe the values that are allowed. So we're going to describe the domain and range in words. Okay, the first thing you have to do is recognize what the domain and range are. So on our first graph, if we have a look at it, it was the same graph that we looked at before. You can start by looking at the lowest point on your graph and the highest point on your graph. So the lowest point, the graph starts down here. So I'm going to read this graph left to right when I'm looking at the domain, and I'm going to read it up and down when I'm looking at the range. That's a good way to remember that. So here's a hint. So when you're looking at the domain, okay, which is our x values, we're going to look from left to right, because we're looking along the x-axis. We're looking from the lowest value to the highest value. And when we look at a range, which is our y values, we're going to look from the bottom to the top. So we're going to look up. So because the lowest value there will be our lowest, smallest value of y up to the highest value of y. And it's a good idea to start with your points on your graph. So again, here I'm starting at, the first point of my graph is at the origin. That's the point 0, 0. Okay, and the highest point that I have here is right here. And that is the point 4 for x, 4 for y. Okay, so that tells me that I can right away figure out my range and I can figure out my domain. Okay, so my domain is going to be this. Okay, well, looking at my graph, I see that the domain goes from, there's two ways to look at it. I can look left to right. So I see that it starts here at 0 and it goes all the way to, oh, sorry, a little bit too far. Okay, it goes all the way to 4. So there's my point. I come down to my x-axis. Okay, it goes from 0 to 4. The other way I can look at it is say, there's the x coordinate of that point, 0, and the highest x value I have here on the far right is 4. So my domain goes from 0 to 4, and I write that like this. I say, the domain is all, this is a continuous graph. In other words, the line is, the data points are connected by a line, so this is continuous data. Let's write that right here. This is continuous data. Okay, because it's connected by a line. So when it's continuous data, we say all real numbers. And we say all real numbers because it's true that between 0 and 4, x could be any number along that line. So it could be 0.1, it could be 1, it could be 1.5, it could be a fraction, it could be any type of number. It doesn't just have to be whole numbers. So it's all real numbers between 0 and 4. And we're going to write inclusive, and that means including 0 and 4. So inclusive means that you also include those two numbers. Okay, that's what inclusive means. Those numbers are included. Okay, the range, looking from the bottom to the top, okay, is going to be from 0 all the way up to my biggest value of y, which is right there at 4. So again, the range is again from 0 to 4. And I can also look at my points. It's going to be the y coordinate here, 0, all the way up to the biggest y coordinate, which is 4. So the range, okay, is all real numbers. Same thing here, okay, between 0 and 4, inclusive. Great. Okay, if we look at a graph below here, we see something different on this graph. The second graph has a open circle, okay? And we need to know what that means. So if you see an open circle, it means that that last data point right there is not included. Okay, that's what that open circle means. So right here, when we see this, okay, that means that this last point, and what is that point? Let's check on our graph. For x, that's the point, if I come down to my x-axis, that looks like it's at 3 for x, and it's at 3 for y. So that means at this point, 3, 3, okay, is not included, or it's not a possible value. Okay, so if you see on the graph, let's fill this out below, a plotted point with a solid dot, okay, or just a solid line there. If you don't, like in the graph above, we didn't see any dots. We could have had solid dots at the end and beginning of our graph. But if you don't see an open dot, it means that every data point that you see is included. So you include all solid dots, okay, or any points on a line. An open circle, an open data point, means that you do not include that point as a possible value for x or y. So that is not a possible point, which means that there's no possibility that x could be equal to that point or y could be equal to the y coordinate for that point. So how do we describe that then? Well, what we have to do is still figure out the domain and range, but we're going to have to say that that last point is not included. Okay, so let's start with our domain. What is the domain? Okay, let's look along our x-axis from left to right. So there's my first point right here, and this first point has the coordinates if I look where I am on my x-axis, I'm back 1, 2. If I come up to here, sorry, my pen's not working very well. I'm at -2 for x. And where am I at for y? Let's come over to my y-axis for a minute here, okay? Looks like I am at -3 for y. Okay, so this is the point, -2, -3. And then it goes all the way up to this top point, and that's the point 3, 3. Okay, 3, 3. But I know that 3, 3 is not included. So my domain, if I look at where my x values go from, they go from -2, okay, all the way over to +3, but then that last one is not included. So how do we describe that? What we say is, again, the domain is all real numbers because this is a solid line. So all real numbers greater than and equal to -2. So greater than, okay, or equal, because -2 is a possible option, to -2. And, well, we can go all the way up to 3, but we can't go higher than 3. And we can't have 3 as a value. So what we say is, and less than 3. And I say less than, and I don't say less than or equal to 3, just less than. And that means that 3 can't be a possible point. It has to be less than 3. So it can go all the way up to 2.9 or 2.99, but it can't be right at 3. Okay, that's my domain. Let's look at my range. My range here in words. Okay, sorry about my pen. I'm not sure why it's doing this. My range is going to be looking from the bottom to the top. So I look at my lowest value of y, which is here at -3. And I'm going all the way up. Here's my range. Up to the highest value of y, which is +3, but that +3 can't be included. So I say the range is all real numbers. Okay, greater than or equal to -3. And less than +3. Okay, less than +3, because we can't have it equal to +3, so we don't write less than or equal to. Okay, great. Let's have a look at how do we describe the domain and range on a number line. Number lines are actually really just looking at the x-axis and the y-axis as two separate axes or two separate number lines. You can think of a graph like the x-axis is really just a number line, and it's sort of superimposed over the y-axis. So you actually have two number lines coming together when you have a graph. And what we're actually really going to do now is just separate them apart again. Think about, well, what are the possible values of x? So from what limit to what limit? And what are the possible values of y? From which limit to which limit? Lower to upper limit. And there's a little bit of a handy hint here. I'm going to go through some of these with you. I want to show you really quickly. In your data booklet, I have given you, if you have a look at your data booklet, okay, after the first page of your data booklet insert, I gave you an insert for the real numbers. And after the first page, on the back of that first page, you have terms and symbols that are used when we're talking about domain and range. And so you actually have some handy hints here for words. So for example, and on yours, you actually have these little graphs filled in. So for example, if points are not included on a graph, it looks like this. Open circles, okay? And we use the words greater than and less than here. So if this was from 1 to 4, okay, so this actually helps you remember all these things. And that's also what it would look like on a number line as well. Okay, we also have on our sort of our cheat sheet here, it says if one of those points is included, so for example, if 4 has a solid dot, but there's an open dot at 1, we say it's greater than 1 and less than or equal to 4. And again, we show what that would look like on a number line. So what it looks like on your graph is the same as what it looks like on a number line. You also have down below here, what if there's no upper limit on a graph? If you have an arrowhead on a graph, that tells you that there's no upper limit. Okay, and so what we say there is that goes to infinity, essentially. Okay, in the positive direction. And in words, we say it's just greater than whatever that lower limit is. Okay, so if it was greater than 1, it would look like that on a graph, and it would look like that on a number line as well. And the same thing is true if there's no lower limit. Okay, no lower limit. Sorry, let me fix that on your graph, the last one there. Sorry, if it's greater than, it means it's greater than 1, but it can include 1. And if it's a solid dot at 1, we say it's greater than or equal to 1. And that's all we have to say, because then it just goes on and on and on to infinity. Okay, so there's no upper limit. And same thing is true about the lower limit. If it's an open dot, we say it's less than whatever that value is. So if that's 1, it's less than 1. Okay, and if it was a solid dot, we say less than or equal to 1. So you actually have all this information on your cheat sheet, so you can use that. Okay, so let's go ahead and do some of these now together. So when we show the domain and the range using number lines, we have to have 2 number lines. We're going to have 1 number line for the domain and 1 number line for the range. Just like in words, you have to state the domain separately from the range. So here's what we need to know. Okay, a couple of things. Inclusive points. Okay, we use a solid point or solid circle, solid data point to show that that point's included. So for example, if in words, let's say maybe we're talking about domain. Here's an example, okay? The domain is from 0 to 10 inclusive. Okay, or all real numbers from 0 to 10 inclusive. On a number line, I can show that. So I pretend that this is my x-axis, and I say, well, I'm going from 0 all the way up to 10, and inclusive means that I connect those with a line. Okay, or I should say 0 to 10 means I connect them with a line. Inclusive means that I'm going to include those 2 data points. So that's what I would write for my domain, showing it on a number line. Okay, let's imagine that for range, we were given in words that the range is all real numbers greater than or equal to 10. Let's put 10 in here. Okay, greater than or equal to 10 means that we start at 10. So 10 is our lower limit, and there is no upper limit. So greater than 10 means that there is no upper limit. If an upper limit is not stated, that means that it just goes on to infinity. So this, it looks like this. It goes from 10 all the way to infinity, but 10 is included, okay, because we see or equal to 10. So the range starts at 10 here. I put a solid dot because it says or equal to, and then I'm going to show my line is going in this direction, and I'll put an arrowhead on it, and that means that there is no limit. Okay, so I'll use the arrowhead means no limit. In other words, it just goes on to infinity. Okay, if it says, let's say we have a different range and it said less than or equal to 10. Okay, again, less than or equal to 10 tells me that 10 is included because it says or equal to. Okay, but it's also less than 10. So I could have values of y that are less than 10, and there's no lower limit. So this tells me that 10 is my upper limit. And it's going to be a solid dot at 10, right here. Okay, so right on 10, solid dot, sorry. And it just goes on in the less than direction, negative direction here, to infinity. So there's no lower limit here. And we show no limits, just like we do on a graph with an arrowhead. Okay, so these are some examples of when we have inclusive points. Let's have a look at some where we have points that are non-inclusive. In other words, open circles on a graph, or in words, we're told that there's no possibility of being equal to some value. So for example, greater than 0, let's imagine that this is talking about my domain. Okay, greater than 0 means that it can be anything above 0. Okay, no upper limit. Okay, so 0 is the lower limit, but if I look at the language, it says greater than. It doesn't say greater than or equal to. So 0 is not a possible point. So it can be anything above 0, but 0 is not included. So what I'll do is I'll use an open dot at 0 here to show that 0 is the first point, but it's not a possible value, and it can be anything greater than it. So we're going to show an arrow in the positive direction, greater than, no upper limit. Okay, but this point 0 is not included, so x cannot be 0, but it can be anything above it. Okay, let's imagine we're talking about a range for the next one. So that means we're talking about our y values here, and it's less than 10. Again, same thing. Less than means that 10, okay, is the upper limit. 10 is the highest value I can have, but it's not included as a data point. Okay, so I put an open circle at 10 here, and it can be anything less than, but there's no lower limit, so I show an arrowhead in the negative direction. So there's no lower limit. Okay, and 10 is not included. Discrete numbers have to be shown a little bit differently. So if you're given, for example, just some specific values in a list, okay, for x, so imagine this is our domain, and it says something like this, like x is -2, 0, 4, 8, and 10. Okay, those are the only possible values of x. That means that there's only a few possible values, and they're all counting numbers. And if you look at your real data sheet, you can see that we have some negatives in there. So that means that these guys are actually called integers because we have a negative value as well. So x can only be the integer values -2, 0, 4, 8, and 10. And so if you have discrete data, okay, we're just given specific points, then on a number line for x, we would just show those points. Okay, and from what we're told, these are all possible values. So we put a point at -2, okay, at 0, at 4, at 8, and at 10. Okay, this is discrete. So we show data points only. We do not connect them with a line unless they're continuous data. Okay, and so if we're just given points, we don't connect them. Okay, so not connected with a line. Finally, when we have discrete data, there's another way that we can express the domain and the range. So we could use a number line, just like this one right here. That's fine, but we can also use a list. So when you have only, say, a few different possible values or possible points for your graph, then we can express them as a short list of x values and a short list of y values. So lists are only used for discrete data because otherwise, if it was real data and there were so many different possibilities in between your upper and lower limit, you'd have a humongous list. So they're only used for discrete data where there's a finite number of possible x and y values, and you have to show two lists, just like you have to show two number lines, one for the domain and one for the range. So if this was our graph and we had data points at these 4 points, we could express this as a list. So we look at it and say, remember that a point on a graph is always x first and then y. So the possible values I have for x are the first values in each of these sets of brackets. So 0, 1, 3, and 6. When we do a list, we use curly brackets. Okay, so we show them as a set. So we would do a curly set of brackets like this, and then we would just put in the x values. So 0, 1, 3, and 6. Okay. The range, let me do the range in green. The range will be all the possible y values. So 0, 5, 7. And I see 7 is duplicated twice. So when I do the range, I use curly brackets and I say 0, 5, 7. I don't have to write 7 twice. So if I have a repeat value, I only have to show it once because 7 is a possible value. There's no need to show it more than once. Okay, so I don't show a repeat value for y or for x. Okay, so those are all the possible values of y in my range. Great. I'm going to stop right there. The next section is going to cover interval notation, and then we're going to tie it all together. So thanks for joining me. Go ahead and you can try some questions on your worksheet 6.3, or you can watch the next video and then do your 6.3 worksheet. Thanks for joining me.